Okay. Okay, come in, let's start class. Papers and warm-ups, please. Will you put the bucket in front of the door? Thank you very much, Michaela. Papers and warm-ups for me, please. Warm-ups, please. Get them out, get them started. We're doing a cool lab today, so I want to get going. What did you do? Okay, warm-ups are getting done. I'm going to take attendance, so get going. We're going to go fast because I want to get started on the cool stuff. There's a lot of people today. If you don't know the answer to the warm-up, where should you find it? In your notebook. Exactly. You need another minute? Yes. Okay. I'll give you another minute. Okay, what is the first law of motion? Someone raise their hand and tell me. Jaden, what is it? The law of inertia. It's the law of inertia. Things in motion stay in motion. Things at rest stay at rest, unless there's some big force that happens. What is the third law of motion? I said third, so don't get confused. What is it, Elias? Action. It's action and reaction. Absolutely. And our second law, Michaela? Force equals mass times. Force equals mass times acceleration. We are going to be using that formula today. Not like super directly, but we're going to make a connection between our lab and that formula and that law of motion. Okay? I'm going to set up your table of contents so you can get that updated and taped in, and then we'll jump in. All right, so it's helicopter lab on page 128 and 129. Make sure you're using your pink table of contents, because that's this unit. And then your pages need to get taped in slip style today because they're both front and back. Page 1, I'll come show you, is the one that says lab paper helicopters. And then page 2 is the side with the graph up. So if you're stuck, this is what it should look like. Okay. Page 1 and page 2. And then just make sure you tape them flip style because you're going to need the back of both of them also. And make sure you're sharing tape with all the tables. So if you've got tape at your table and you're done with it, make sure you're passing it around so that everybody has what they need. Do we need tape over here? Okay, so while you finish taping, I'm going to tell you what group you're going to work in, because I want you to be in groups of either 2 or 3. So I'm going to come around and kind of divvy you up right now, okay? So you 2 are going to work in a pair, you're going to work in 2 or 3. You 3 are just going to work together. You 2 are going to work together, you 3 are going to work together. And then 2, 2, and 2, and 2. Okay. Okay. Are we done? Are we good? Do you need tape? Okay, is everyone taped, ready to go? Yes. Fantastic. Okay, so what we're going to do is create helicopters to do a lab. It should be pretty fun. It's a review of a little bit of physics, like that second law of motion like we talked about, and a whole lot of scientific method, because again, I want you to be as prepared as possible for your final that's next week, okay? So we are going to be doing our helicopter lab. Let's review. Any questions so far? Okay, so on your 2 pages, it kind of walks you through what's the first step of the scientific method. Do we remember? Lane, what do you think? It's before a hypothesis. That's early on, but it's not the first one. Michaela? It's before formal question, but you're right there. You guys are going backward. It goes hypothesis, and then problem, and then what's right above the problem. Use your notebooks, because that's where the answer is. Any ideas? It's literally right here on this page. Michaela, what do you think? Kylie? Observations. You have to notice something in order to come up with a problem, right? Like, I noticed that when I run for a mile or do pacer for, an hour, then I get really tired and then I come to my next class and I'm like super worn out. That's an observation. And then I come up with my problem and hypothesis. So on this paper, it literally goes observation, problem, hypothesis. It walks you straight through the whole scientific method, okay? Before we jump in from the beginning, I want you to flip 128 over and look at the procedures section, because that's going to be where we're starting. Would someone read that first procedure out loud really loud for us? Kylie, do it really loud.
Read background information to determine what your independent variable will be. What will you change? Weight, paper clip, size, or paper type?
Perfect, thank you. Who wants to read the second one for me? Anthony, tell me.
Complete problem hypothesis and experimental design based on.
Perfect. After those 2 procedures, it says, stop, get teacher approval before moving on. That means you're going to stop, and then on that line, I'm going to come and sign it so that we all know we're on the same page. Okay? So, just like they said, you're going to come up with your independent variable, and we're going to set up our experiment before we start actually doing it. Okay? So, helicopter labs. Have any of you ever seen those seed pods on trees that when you throw them really high up in the air, they like spiral down?
Yeah.
That's like the nature design that we built these helicopters off of. Okay, they're going to spiral down just like those leaves do. Okay, so there are a whole lot of things you can test with these helicopters to kind of make it simpler for us. I've broken it down into 4 possible independent variables. Okay, so if you look around the room, there's 4 posters. This one says helicopter weight. Could that affect helicopters and how they fly? Yeah. This one says helicopter paper weight, like some of the paper is really thick, some of it's really thin. Could that affect how a helicopter flies?
Yes.
Totally. Helicopter size, big or small. And helicopter wingspan, like if the wings are really short or if they're really, really long. Okay. So those are in your group, you're going to pick one of those 4 independent variables to kind of base your helicopter off of. Okay. In your group, you're going to be creating 3 helicopters. You're going to have 1 control group helicopter, and then you're going to have 2 helicopters that are for your experimental group. Okay? So I will walk you through that in your groups if you get stuck there. The first thing I want you to do in your groups is read through this observation section. You can either read it to each other if you want or read it on your own, but I want you to read that section. I'll give you a minute or two. It kind of walks you through how to build the helicopter and a little bit about the lab in general. So read that now, and then we'll move on. Anyone still reading? No, we're good. Okay, so every single helicopter comes on a template that looks like this. And the biggest thing to remember from those paragraphs you read is that you cut the solid lines and you fold the dotted lines. Okay? When you do start folding, you're just going to go in alphabetical order. Fold A, then B, then C, then D, then E. Okay? And I'll come around and help your groups if you have a hard time once we get to the assembling spot. Okay? Every group is going to have a control group. It's the one, what are control groups for? Why do we use control groups? It's for comparison, right? That's all it's for. So this size is going to be your control group. Every single group is going to make one. And then you're going to make 2 other helicopters based on whatever independent variable you decide in your groups. Okay? The next thing you need to do in your groups, you're going to have to start working together. You need to come up with your problem hypothesis. And on the back of 128, start filling out your experimental design chart. Okay? So in the problem, it says, what effect does blank have on flight time of the paper helicopters? Your goal here, your effect, as in the cause and effect, your effect, is how long the helicopter stays in the air. That's what you're trying to do. You're trying to see how long you can keep a helicopter flying. Okay? Okay. So what do you think is going to go in that blank? What effect does blank have on flight time? What do you think is going to go in there? It's always the same 2. I want someone else. Be brave. It's okay if you're wrong. What do you think, Anthony? Why do you think it would be weight? Okay. That might be an example, but it's not. I need like the big category. What would fit in that spot? This is where. What do you think it would be, Michaela? Your independent variable, your cause, right? So how does my independent variable, whatever I'm going to pick, so like Anthony put weight in there because I'm assuming he wants to test the weight to see if that's going to affect how they fall, which is one of the categories he can pick. So how does weight affect how my helicopter falls? Perfect problem. Okay, so now's your time to pick your independent variable, work with your group, make sure you are happy with the one you picked, and start filling out the problem hypothesis and experimental design. Go. Okay. So remember there's 4 options. If you don't remember, they're around the room. And the title's on the top, so that might help you. What do you think?
Size.
Okay, what do you want to say? Yeah. Think about it, start writing it down. Keep going. What are you guys going to do? Wait. Okay, so keep going. If you have your problem filled out, then move on to your hypothesis. What do you guys think? Oh, paper type, gotcha. Sorry, you said type, I thought you meant a different model, not a different type of paper. So make sure that's being specific, because you said type to me, and I was like, you're gonna make a different design of helicopter? That'd be awesome. So make sure you're making that specific. What do you guys think it says? Helicopter size. Cool. No, do this one first. So remember, you need to do pretty much all of page 128, and then let me know so I can sign it off before you start building. What are you guys So now, see, some of these we've already talked about. You just gotta when you get to experimental group, you need to have two there. Remember, I said you're gonna make 3 helicopters. So the control group helicopter has 1 paper clip on it per weight. So what 2 other ones are you going to do? Are you going to add more weight to one and less weight to another, or more weight and then more weight? Things, I mean, you can choose, just things to think about. Okay, so remember I hypothesis if we do the independent variable, then the dependent. So that should help. That's your cost, right? So if I use like a really heavy type of paper, do your hypothesis. Do your hypothesis correctly, it won't be like that. If I do this, then everything yes, because you don't. Okay, you should only do one, because if you test more than one variable, then you don't know what's causing. So you should either pick the size of the helicopter or the type of sequence. So which one do you want to test? So there's like a standard size that they'll all be different paper size. Different paper types, all sizes will be the same. But if you do different sizes, then you have like a little type of. If you don't want to have two different pictures, then you don't know what to test. Then you can't tell if you're an independent. If you're done and you need a signature before you move on, raise your hand. What are we thinking? So be more specific than your weight. Like, how are you going to add that? Okay, so how many paper clips? Okay, so no paper clips on one. Your control group is automatically going to have 1 paper clip. So what are you going to do the other? So how many? Okay, write that down. Remember, science is all about being super detailed. How are we doing over here?
The size of the sugar and even variable is
Exactly right. Your dependent variable is like that, how long it stays in there. So then what's your head? Figure out what. Okay, so if there is a giant helicopter or a teeny helicopter, and then we test it doing these things, what's going to happen? So we don't care about higher, we care about how long it's in the air. So do you think if it's smaller, it should stand there longer?
Yeah.
Then write that down. Okay, so if there is a small helicopter, and then we test it with all of these different groups and variables, then what? Then it will, because what does it say? Then the helicopter's flight time will be, okay, so you think if it's smaller, it's gonna be in the air a shorter amount of time? You write that down. That's what you just told me.
Smart people have to ask questions.
Yeah, but we
What we
think
do.
about like.
Oh, sorry, you're ready for me, let's check it out.
Yeah, figure it out.
What else could be constant variables? What are you doing? Okay, good. What else? Does that mean stay consistent? Their wing size decrease. But proportionally, they're gonna be the exact same. Like, it's bigger, the wings will be bigger, but it's the same size compared to the rest of the helicopter. You know what I mean? But I could still make the wings on the big helicopter like this big, and the wings on the small helicopter this big. Right? So that's what my difference is. Or does it matter if, like, what if I have, like, these things that stand next to me and one down there? Is that gonna change it? Because the height of where we drop it changes. I'll be back in a second.
No, right.
Can I have your attention, everyone, in 5, 4, 3, stop talking, 2, holding stop, eyes on me, and 1, okay. I know you guys are getting close to having me sign off to start the next step. I want at least 3 control variables. Okay, I don't want just one, I want at least 3, because so many things have to stay the same. The constant variables, control variables. Okay. Well, go ahead and grab your papers and I'll let you know what group to be in. Where's a group of 2? Perfect. I'm gonna have you join Giovanni and Leo, just so they can help you catch up. Okay? Yes.
Yeah, you guys are
Okay, so remember I said everybody's gonna have a constant helicopter going to these. Okay, so that would be my computer there. Something to compare to. We're just gonna have a plain regular helicopter. So that's my control. And then what are my Wait. Okay, so are you gonna have a helicopter that has a little bigger helicopter that has a bigger? Okay, let's say the same. So are your experiments? Okay, are we ready now?
Yeah.
Now, I want you to grab your supplies from green, so that you're doing side of right, and then bring it, and then come back to your. Yes. So grab the green. No, you just per group, you just need one of those. So grab your supplies at the station. You need one. Oh, you're doing well. You just make sure you're grabbing the right number of papers. And then you're gonna need a supply tub for spinners. And I'll come check in and make sure. How are we doing? Are we ready yet? What are we studying? Okay, so what are you comparing your experiment? Are you gonna have just like a regular size helicopter? Yeah.
I'll do a
Regular size helicopter.
Cut straight lines in your.
No, number cross the six. They're independent variables.
Well, there, it's in it all.
That's what I said. Okay, so then what would your experiment be? What's your independent variable?
is the one we test.
Okay, so how are you gonna test the size?
That
makes no sense. How are you gonna test the size? Are you gonna have a really big one and a really small one? You need to be more specific than that. You need to tell me two different things for your experimental group. How are you gonna test? Yeah, control group is one thing that you're testing, it's just their first comparison. So if I have a medium-sized telecom wire, because that's my control group, that's the one that I'm keeping constant. How am I gonna test other sizes? With our kids that are different as you get. Have a big one and a small one. There you go. Okay, so make sure you go to the right station, grab your thing, you need one paper clip for each one. Your table can be the slide section, you're gonna control this. Are we ready?
And what's our concentrate?
So you need two experiments here. Wait, so what does no weight mean? On this, we measure weight in paper. So, how many paper? Okay, so the weight is gonna be 0 paper clips, that's what we measure. And then what are you gonna do for your experiment? If you have to, you're gonna have 2 of them in your test. So is one of them gonna have 1 paper clip and one of them gonna have 2 paper clips, or 0 paper clips? Those are the things you gotta think about, you have to know what you're testing. So you should have 3 helicopters for your group and only 3. Because then you're going to test each one 3 times. It can be. But your experimental group is weight and size. You're testing the size of the car. So what are you, how am I going to compare my Here we go. Hold A, hold B, hold C up. Your paper clip will go here. And then these hold different C factors. Your wings just have to be folded opposite. Oh, yeah. See, look, wait. All right. Okay, get going so that I can sign you off so you can get started. Looks like we've all just decided to help other people go first. You can catch up, you don't have to wait for her. She'll catch up.
Whoa, that was crazy.
Okay, well, what's our
The one you're comparing. So it's gonna be like every single control helicopter for this experiment is this size with 1 paper. That's the control group helicopter. Ours is here, so that's your control group, the constant one. And then you're gonna vary off of this to get your other.
So we'll do it from your height.
So you're gonna grab your helicopter, make sure you grab all your maps for your section, and start building, because we gotta get going fast.
You're 5'5". I'm 5'5" and a half.
On your solid, that's the directions that. Are you ready? Do you have your stuff? Great. So now you're gonna need to grab. One of you is got one too. One of you is gonna drop them, the other one's gonna measure. You need to fill out your chart. Don't forget to fill out your chart. Everybody. So you're gonna write this. Record. So one of you, one of you can Hold it. Hold it.
I know you were gonna say.
That's for the beginning.
I don't know, you can
We should be working on our helicopters on our tables, not just.
She's gonna be skydiving also.
I didn't say that. I said, based on the
No, it was
What's helicopter?
Oh, that's ours.
I wanna do art in there.
Dude, why would you?
Wait,
First of all,
What other things we did think so that I'm only testing this out? It's not really what you do that at work, but that's When you drop your helicopter, stay on the ground. Do not stand on anything else. Don't throw them. You're just going to drop them from where you are.
Wait, what if we said we're gonna throw? All the way.
How can you keep that racist in there? And you can make it sure it has the exact same place every single time, and nothing changes at all. Yes. Wait, where did you gonna do the zero then?
I got everything.
Your group is doing it with you. You're gonna be timing and dropping as the same person. That's why you have groups.
Oh my god, it's just.
Over here.
It is the same one.
So one of you should be timing and recording that. The other one should be dropping. Okay, okay. On the One minute. Well, whichever one is heavy.
It goes like 1 minute and 20 seconds.
If you look over there, it's so the timer should be the one to say what, because there is difference in timer exactly what it's. No, it is 3 to 1. Are we doing? So it shouldn't be example number 1 and example number 2. What did you do? So what are you doing? What did you do to your second helper? How many? And write that down. Yeah. That is, it's gotta be like that. You gotta have a detail. This is all one experiment. What did you do? Because you have one control helicopter, one thing doesn't matter. And then what is the other helicopter? That, what that would be. Okay, you need to be done testing your helicopters in the next 4 minutes or so.
Alright, go. That one. Alright, wait. Alright, wait.
Hold on, A. Don't cut on the dotted line. Cut on the collar. So you cut here and here and here. No.
Whatever.
No. Okay, now that you have your data, I want you all to sit down. You're gonna don't forget to be recording your data in your chart.
1 second.
Okay, don't start testing.
You do that. Okay, we'll do the better one. So that was this. Alright, now grab the next one.
So you're testing, we got So, once you're done with your data collection, you need to average all the times together. Then you're gonna graph the average only. What kind of graph? There's 1.53. Ow, I wanted to do again. Now you have your next helicopter. What, call by your helicopter. Yeah.
We're gonna end the
So then you're your next helicopter. What's your next helicopter?
Yeah,
let's do it one more time. Look, this says.
You guys ready?
Then you're gonna take your other round, or their big helicopter.
They're also spent how.
Oh my God,
3, 2, 1, go.
I'm gonna stop you wherever you are in about 6 minutes, so make sure you're working quick when you start getting things averaged and total. We should be just about done testing now.
Alright, so.
So you might need to adjust your numbers too, because I just predicted based on the half year's number. and therefore really low. So if yours are higher than that, you just need to agree to, like, so you can like cross out the numbers and make your own. If she gets.
Good question.
Yes. What? What did you have? What does the title say? It says helicopter type. So you have your control, then whatever type of helicopter you have. And then you put your data, your chart, your testing, each one of our helicopters every time. With you, there's something if your numbers are off,
One, two, three. 151.
Okay. So make sure you're working on your averages. And then you need to make your bar graphs or your analysis.
Yes. One, two, six.
You tell me. So your flight time is one variable that you have to decide. What's another thing you have here?
Add all three of them.
What's your independent variable? What's your independent variable? Okay, so you test different weights, right? So that's what would go at the bottom. And then on your little lines, you need to tell me what you did for each one. Like what experiment one, what type, what did that helicopter, how is it different? Those are the little lines, and the big line is your independent variable. Okay, we've got to collect our data way faster. You should be dropping and writing down numbers. Do the averages later. Drop and record. Drop and record. How are we doing over here? Yes. Good. Good.
The type of weight.
One, two, three.
Yeah, they're going to be more like they're around three numbers. Are we doing it? Good. Are we graphs to start? So should be 1.25.
Let's do that.
How are we doing? Good. Now, over here, we're setting our graph over here. Just cross these numbers out every number.
1.2.
Like the highest one or just.
While she's figuring out averages, start labeling the parts of your graph.
One flat.
How are we doing? Did you renumber?
Numbers are too
Renumber
small.
this. So we have to add the ones, and then don't forget your, well, you at the top, you your title. Draw the bar graph. We have to write it. And we wait for it to draw the bar graph. And then flip it over to the back, you're gonna know. All right, I need you to stop where you are and just listen. That means we're not writing, we're not talking, we're not dropping helicopters. We're done talking and we're listening. The bell's gonna ring in about a minute and I need to get information out to you. So, tomorrow we're gonna finish the analysis and conclusion if we didn't quite get there. I mean, when I say go, for all supply tubs, I said when I say go, for all supplies to go back in the tubs and tubs to be put away, I need every single paper scrap picked up off the tables and floors and thrown away. If you want to keep a helicopter, a single helicopter, you may. Otherwise, The paper clips are coming off and getting put on my desk, and all of the paper is getting put in the recycling. Any questions? Okay, go.
You want to keep, how much are we starting?
So papers are getting thrown away, paper clips on my desk, supplies away, chairs stacked, no trash on the floor, all those little scraps have to be picked up. Where does this helicopter go? Jason, put it there. Gentlemen, this supply can be put away. Chairs need to be stacked, you're done. If you don't want it, thank you for stacking my chairs. These supplies have to and then we are by our seats till the bell rings. By our seats till the bell rings. Have a lovely day. I'll see you tomorrow. Bye, Jaden. Well, I'm glad you got caught up.
Bye.
Goodbye. Goodbye. Oh, that's perfect too. Thank you.